everyone. Welcome to Physics by Aryan. I'm very happy to welcome you all. So today is our first lecture of our free foundation physics course. The first topic which we are going to cover in this course is graphical analysis. So graphs are really a very important tool in physics. So if you want to make your physics journey very easy, then you must have a very good knowledge of graphs because they helps us in almost all the subjects, not just in mathematical physics or classical mechanics. Whatever subject you pick up, you will always see a graph in a physics textbook. So we should be very good in understanding the graphs, analyzing the graphs, and how we can extract the information from the graphs. So in next two lectures, I will be covering up each and every aspect that you must know about the graphs. We will be covering different types of graphs, and then we will be going towards the applications of graphs in physics. So let's just begin. The first graph which I want to teach you is linear graph. So linear basically means straight line. So straight line graphs. In order to draw any graph, if you want to plot any graph, the number one thing that you need is an equation. You need an equation, only then you can plot a graph. So your equations usually look like this: y equals to mx plus c. If you want to plot a straight line graph, or if your equation is a linear equation, then your equation will look like something like this: y equals to mx plus c. Now here y is a dependent variable, x is an independent variable. So the graph is always plotted between two or three variables. One variable we keep it on x-axis, other on y-axis, and another one on the z-axis. So the first variable which we keep it on the x-axis is known as independent variable. Why independent? Because this variable can take any value. You can give any value of x. Let's say you can say my x is 1, my x is 2. Whatever x value you want to give, you can give. And whatever you give x, accordingly, you will get some value of y. So the value of y is actually dependent on the value of x. So that is why the y is known as dependent variable. However, the x is known as independent variable. Now this equation which you are seeing here, y equals to mx plus c, is an equation of a straight line. In this equation, your m is known as slope. Slope of an equation, I will tell you what is slope actually is, and the c is known as y-intercept. So whenever your equation depends directly on x, let's say your y is only dependent on x to power 1, or let's say your velocity is dependent on t power 1. All these sort of graphs where your dependent variable depends upon independent variable raised to power 1, then the graph that you will get is straight line. In order to draw straight line graph, you basically need two parameters. One is slope and other is y-intercept. So let's try to understand what is slope and what is y-intercept. So let's say, let's consider this graph. So this is a straight line graph. You all can see this is a straight line graph. So one line is going like this, as you can see in the graph. Y-intercept is known as the point where your graph actually cuts the y-axis. If you see your graph is cutting x-axis at this point. So this point is known as y-intercept. So the point where graph actually cuts the y-axis is known as y-intercept. Or you can also say that the value of y when x is 0. So at this point, if you see x is 0, at this point, if you see x is 0 and the value of y is c. So the value of y when the x is 0 is known as y-intercept. Or in other terms, the point where the graph cuts the y-axis. Okay. So this is all about y-intercept. Now let's talk about slope. So slope of a line or a slope of a graph is how much inclined that line is. How much inclined this line is. So as you can see, this line is completely flat. So slope is 0. It's like a straight road, very smooth road. So incline, no inclination is there. So this is completely no slope or no inclination is there. So this is slope 0 line. But if you see, I give some slope, I give some inclination. This is non-zero slope. This is, let's say, M1 slope. Now I can give even more slope. This will be M2. So you can clearly see the slope of M2 is greater than M1. So what slope, basically in a layman language, what slope is? That what is the inclination of the line? How much angle this line is making with the x-axis? How much angle this line makes with the x-axis gives you the idea of slope. So how we can define slope? The number one way to define slope is m equals to tan theta. So your slope is equals to tan of theta. And what is theta here? As I mentioned, theta is an angle which your line is making with x-axis. So let's see in the graph, you can clearly see the theta angle your line is making with x-axis. So if your line is making theta angle with the x-axis, then your slope will be tan theta. That is the simplest thing that you should remember. Now, the next point, slope can be defined in other ways as well. One more way to define the slope is by taking the derivative. So slope is also defined as derivative. So what is derivative? Derivative is nothing but change in y with change in x. This is the basic definition of derivative or the differentiation that you might have heard. If someone tells you what is derivative, then you can simply say the change in y with change in x. So that is what exactly I have defined. So your slope m equals to delta y, which means change in y divided by change in x. That is known as slope. That is one of the other definition of the slope. So we define slope in two ways. One is m equals to tan theta, and also m is derivative or the change in y divided by change in x. Now these all things might look very boring or very general. So let's try to understand what I have told you through some examples. So I am giving you two graphs. Here I am giving you two graphs. Number one graph you can clearly see, and number two graph. In both the graphs, we want to find the slope. So let's start finding the slope in the first graph. So slope in the first graph, as you see, no angles are given to me. I do not know the angles. So if I don't know the angle, then which of the definition I should use? Second one. Because I don't know the angle. So to find the slope, the best way is we can use the second equation, which is change in y divided by change in x. So let's try to do this. So here I have written change in y divided by change in x. Okay. So what is change in y and what is change in x? So in the graph, I'm starting from here. So my x1 is 0 and my y1 is 3. And I am going to this point where my x2 is 4, but my y value is 0. So at this point, you can clearly see your y is 0, but your x is 4. And at this point, you can clearly see your x is 0, but your y is 3. So now all I need to do is y2 minus y1 divided by x2 minus x1, because that will be my change in y divided by change in x. So let's do it. So I can do it is my x1 is 0, y1 is 3, x2 is 4, y2 is 0, as I already mentioned. Then my slope will be y2 minus y1 divided by x2 minus x1, which will come out to be minus 3 by 4. So you can clearly see the slope is negative. So what does a negative slope means? That your graph is actually decreasing in y. So negative slope means graph decreasing in y. So your graph is clearly decreasing in y, or you can say your inclination is downwards. If I put a ball here, the ball will slide down very smoothly. So since it is sliding down, the slope is negative. Okay. So this was one of the ways to find the slope. Now let's find the another way. Second way is I am giving you the second graph. Now, I don't know any values of y or x. I don't know what is y, what is x, but I know the angle. So which formula I should use? Yes, you are right, which is m equals to tan theta. So what is my theta? Theta is an angle which my line is making with x-axis. So that is given to me, which is 120 degree. So my tan 120 degree will be the slope, which is known as minus √3. Again, you are seeing your slope is negative. Again, you can see your graph is decreasing in y. That is why your slope is coming out to be negative. So that is a point which I wanted to make sure. So what we studied so far, we studied that what is linear graph. When y depends upon x power 1, then the graph is linear. And the equation of linear graph is y equals to mx plus c. And in this graph, m is slope and c is the y-intercept. And then we learned the two ways to find the slope. And we did the example for both of those formulae. All of this information you can clearly read in the notes provided on the course page. So you can go to the course page and read the notes. That will be very helpful. After the lecture, you can clearly read the notes. Now, let's move to the next. Now, the second kind of question which I want to give you. So this is how the lectures will go. I will not waste so much time in deriving the things, but I will be giving you a lot of sample problems, or I will be teaching you how you can look at one formula from the different point of views. That is my expertise, and that what I will be doing in the classes. So second question is that find the equation of graph. Now they said, we are giving you one graph. Please find the equation of this graph. So the graph is given to us. This is given. Now, as I mentioned, once we saw the graph, we saw that it is a straight line. So it's a straight line. So we clearly know that the equation of this graph will be something like y equals to mx plus c. This we know. The only two things that we want to know is one is c and other is m. So what is c? C is the point where line cuts the y-axis. So you can clearly see the line is cutting y-axis at this point, which is -2. So your c is -2. Y-intercept is -2. Now what we want to know is, we want to know the slope. Again, we will use the same method to find the slope. So this is my x1 equals to 0 and value of y1 is -2. At this point, my x2 is 1, but my y2 is 0. You can clearly see that on the first point, x is 0, but y is -2. And on the second point, x is 1, but y is 0. So now I need to do simply is y2 minus y1 divided by x2 minus x1. So that is what I did here. Y2 minus y1 divided by x2 minus x1. So once I do, I found that slope is 2. So you can clearly see now your slope is positive. Why? Because your graph is increasing in the y. So once your graph is increasing in y, the slope is positive. But if your graph is decreasing in y, your slope is negative. So we know now the slope, we also know the intercept. So let's just put the value. So at the place of m, I will put 2. And at the place of intercept, I will put -2. So this is my equation. Y equals to 2x minus 2. So I got the equation from the graph. So remember, this is need to be used at many places in physics. In physics, where you will be given some sort of graph, and you might need to find an equation of that graph, especially in the case of linear graphs. So this example is very important that you understand it very carefully. In case you have any doubts, you can either give me a comment or message me, or you can even comment below this video on the course page or on the YouTube. And on the Sunday, I will be taking a live doubt class where you can actually ask me any question in the live doubt class. Okay. Now let's move to the third. Now, in first two examples, graph was given to you, but now the graph is not given to you. Equation is given to you, and they are asking that, okay, find the graph. So what they are saying, v equals to minus 2t minus 3. So now your y-axis variable is v and your x-axis variable is t. So, and you need to plot v versus t. Since v depends on t power 1, since v depends upon t power 1, this graph will be linear. So let's do the linear graph. As you can clearly see here, this is your c. If we compare it with y equals to mx plus c, then this minus 3 is your c. So your y-intercept is minus 3. So I started my graph from minus 3. And your slope is negative. You can clearly see m is minus 2. So you need to decrease your graph in the y-axis. So you will start from minus 3 and start decreasing your graph. You will get the graph which is shown here. So whatever is your y-intercept, start the graph from there. And if your slope is positive, increase the y, or if your slope is negative, decrease the y. So take either line up or line down. So in this graph, my slope was negative. So I took my graph down. Now let's practice this in second example. So here you can see your y-intercept is 1. So I will start my graph from 1. And my slope is also positive. So I will increase my graph. So starting from here, I will increase my graph. So you will get this curve. Very simple, very easy concept. Next, let's go to next. Now you can clearly see your intercept is minus 3. So your intercept is minus 3. And your slope is positive. So starting from here, you will increase the graph because your slope is positive. If your slope would be negative, it would have gone down. But in this case, slope is positive. So you started from minus 3, but you increased your graph because the slope was positive. Now in the last example, let's see. Now in this, your y-intercept is plus 3. So you will start your graph from plus 3. But your slope is negative, so you will decrease the graph. So I decrease the graph and I got this graph. As simple as that. So whatever equation is given to you, you can easily plot the graph. Okay. So I hope you have understood that once an equation is given to you, how you can actually plot the graph. Okay. So let's move on. Next point. Now, the last point which I want to mention in the linear graph is let's compare the graphs. So now I am giving you two equations. And I want you to plot both the equations in the same graph. So you can see the y-intercept of both the graphs is same. So both will start from the same. But the slope of first graph is less and the slope of second graph is more. And this is what I am seeing here. The slope of first graph is less and the slope of second graph is more. So this is what I am actually looking at here. So you can do this kind of analysis that if two graphs are given, so you can just by looking at the graph, you can say the slope of V2 is greater than slope of V1. Just by looking at the graph, you can tell this. So I hope you have all understood the linear graphs. So I will recommend you, please do some solved examples of the notes. I have added some solved examples and unsolved problems in the notes. In the notes, you can see and you can practice those equations. That will give you a very good practice that whatever you are learning in the lectures, you can actually implement those by reading the notes itself. So let's move to the next part, which is quadratic equations. In the last linear graphs, y was dependent upon x. But let's say now your y is dependent upon x square. The maximum power on which y depends is x square. In that case, your graph will be parabola. So let me fix this. I think there is something little bit wrong here. So let me fix it. So your a x square plus bx plus c is known as parabola. So you can clearly see the maximum power of x to which y depends is x square. So this graph which we are getting is parabola. So the equation, when the equation is quadratic, these kind of equations are known as quadratic equations. So when the equation is quadratic, the graph that you get is parabola. Okay, so let's practice it. So once, first example you can clearly see is y equals to x. Whenever some equation is given to you, number one thing that you need to do is, what is the value at x equals to 0? So always ask yourself that what is the value at x equals to 0? So I can clearly see if I put x equals to 0, my y is 0. It means I know that I have to start my graph from origin. Second question that you need to ask is shape. What will be the shape of this graph? So the shape of this graph will be parabola. Why? Because y depends upon x square. So I will draw a parabola. Now, if you clearly see that if you put x positive, even then your value is positive. So let's say I put x3, then your y will be 9. Or let's say you put x minus 3, even then your value is 9. So you can either make your x positive or x negative, but your y will always remain positive. So this is how your parabola will be formed. You can clearly see that your x is going positive or negative, but your y is always remaining positive. So that is how you make a parabola. So this is known as upper parabola. Upper parabola. Now let's do one thing. What I will do is I will add plus 2 in the equation. So my now new equation is x square plus 2. Again, I will ask the same question. What if I put x equals to 0? Then my y will be 2. So it means I need to start my graph from 2. And again, I need to make a parabola. So I will again make a parabola. So what does this 2 did to the graph? What is the effect of this 2? So this 2 only shifted the entire graph. So this 2 shifted graph by plus 2. So you can actually see that if you add 2 in your value of y, in value of y you added 2. So everywhere your graph will go up, and your this graph, first graph, will be shifted by plus 2 in the plus y axis. Okay, so that is how we make a graph of y equals to x square plus 2. Now let's do more examples. Let's see. Now your graph is y equals to minus x. Y equals to minus x. Now you clearly see at x equals to 0, your y is 0. So I again need to start from origin. But now if you see, if I put plus 3, my answer is minus. If I put minus 3, still my answer is minus. So you can put your x positive or negative, but your y will always remain negative. So what you will get is lower parabola. This is known as lower parabola. Whatever value of x you put, your y value will always remain negative. That is what we saw. Again, I added 2 in this graph. So y equals to minus x square plus 2. So as you can predict, your entire graph will go up by 2. So you can see this graph and this graph. This graph has gone up by amount 2. So that is how you actually make the parabola graphs. Okay, I hope you understood this. Now let's move to other parabola graphs. Now I am reversing the equation. Now my graph is not y equals to x square. It is not y equals to x square. Instead, it is x equals to y square. Now let's begin. If your x is 0, your y is 0. So you need to start from origin. Very good. We have understood this. But now you clearly see, if you put y as 3, your x is 9. Or if you put y as minus 3, your x is still 9. So whatever value you put, so you can put y as plus or minus, but your x will always remain plus. So what graph you will get? You will get right parabola. This is known as right parabola. Now let's make left parabola. So left parabola is y equals to minus y square. So if you put y as 3, your x is minus 9. Or if you put y as minus 3, your x is still minus 9. So you can put your y as positive or negative. Your x will always remain negative. So that is how you get a left parabola. So you got a right parabola, you got the left parabola. Okay, now again, let's play with them. So I added +2 in the equation. Initially, my equation was x equals to y square. Now my equation is x equals to y square plus 2. So again, as you can predict, your x value, you added 2 in your x value. So 2 has been added to x value. So what will happen? Your graph will shift +2 in the x-axis. So your entire graph has shifted +2 in the x-axis. Similarly, you can see here, your graph was minus x equals to minus y square, and you added +2. So you can clearly see this graph will be shifted by +2. So if you shift this graph by +2, you will get this graph. So you just have to shift your graph by +2 towards the x-axis. So I hope that you have understood that how to solve this kind of parabola questions, or once an equation is given to you, how you can actually find the graph. Okay, so let me give you one more example. These kind of examples you will actually see in harmonic oscillators. So in physics, there is a concept known as simple harmonic oscillations. So whenever there are harmonic oscillations, then you see the potential. So in physics, whenever there is a simple harmonic oscillations, the potential is quadratic. So you must have heard potential energy as half kx square in the case of spring or in the case of pendulum. So once you see this energy in case of spring or pendulum, then you can clearly see your graph is parabola. So parabola graph is very important graph, or quadratic graph is very important graph in physics, because at many places we see simple harmonic oscillations. So let's see here. If your graph is y equals to x minus 2 whole square, x minus 2 whole square. So you can clearly see that when x is 2, your y is 0. So what happened here? What has actually happened? So your mean position has shifted. Now your mean position has shifted. Now your y is not 0 at x equals to 0. Initially, what was happening? At x 0, your y was 0. So your mean position was 0. But now your y is 0 at 2. So now your mean position is 2. So you will start your graph with the mean position at 2, and you will again make a parabola. So this is how you plot a x minus 2 kind of graphs. Let's say I give you y equals to x plus 2 square. Then what will happen? Your y will become 0 at x equals to minus 2. So now your mean position is minus 2. So this is your mean position. So your graph will be like this. Okay. So I hope that you understood this concept, that how the graph can be plotted if instead of x square, it is x minus a square or x plus a square. Okay. So this was all about quadratic graphs. The next part which I want to cover is power graphs. Now in physics, many times you see y equals to x square graph, y equals to x cube graph. Okay, so let's cover y equals to x square graph and y equals to x cube graph. So you can see actually one graph is y equals to x square and other is y equals to x cube. So y equals to x square, will be parabola. So white graph you can clearly see is parabola graph. But y equals to x cube graph you can see is given by yellow. So what are the features of yellow graph? Number one feature is when x is negative, y equals to x cube is also negative. So you can clearly see x cube is an odd function. So if you put x as negative, your value of y will also be negative. So you can actually see your graph is also going towards negative y-axis. But in x square case, this never happens. When your x is negative, your y still remains positive. So your graph always remains in plus y. But in x cube, your graph will also go in the minus x direction. Minus y direction. What is the second feature? X cube graph grows fast. X cube graph grows fast. So both the graphs reach the same value of y. Both the graphs reached the almost the same value of y. But you can see it took less amount of x to reach y. So yellow graph took less amount of x to reach y. But the x square graph took the more amount of x to reach the same value of y. So x cube graph reached the grow very fast, but the x square graph grows little slowly than x cube. So x cube graph is a fast growing function, but the x square graph is a slow growing function. That we can clearly see from our graph. So whenever you need to compare x square and x cube graph, number one is x cube graph will also go towards the negative y axis. And number two is your x cube graph will grow very fast in compare with the x square graph. Okay, let's compare more graphs. Two more graphs which I want to compare is y equals to 1 by x square and y equals to 1 by x cube. Again, the same thing. 1 by x square graph will always be positive. So how do you make 1 by x square graph? That is a number one question. So let me show you how can you make. So at x equals to 0, you can see your y is infinity. If you put x 0, your y is infinity. So your graph will come from infinity. And if your x is infinity, your y is 0. So your graph will come from infinity and it will go to 0 as your x goes to infinity. Similarly, in the negative side, your graph will remain positive. Why? Because it is 1 by x square. So if you put x positive or negative, your y will remain positive. So this is the graph for y equals to 1 by x square. Now, what will be the graph for y equals to 1 by x cube? See, in this case, your graph, you can see the yellow graph, right? Yellow graph will also go to the negative side, because if your x is negative, your y will also be negative. So your graph will also go to negative side. Also, the decay of 1 by x cube is fast. So 1 by x cube will decay very fast, but 1 by x square will decay slow. Why this is the case? Because you know x ki power. So if x power is more, the decay will be very fast. Okay, so we can clearly see the yellow is decaying much faster than the white. So white graph is 1 by x square and yellow graph is 1 by x cube. So you can clearly see your 1 by x cube graph is decaying very fast and your white graph is decaying little slow. So again, the same features we saw. First feature we can see is positive, negative, and second, which will decay or which will grow fast. So these are the two features to distinguish between the graphs. Okay, I hope that you understood till here. The next part which I'm going to cover is rational functions. What is rational functions? That is also very important part. So you can, if you think the lecture is going fast, so what you can do is you can pause in between and you can make your notes in between the lectures so that you can actually understand. If you want to look at the notes along with the lectures, that is also possible. You can see the notes in parallel with the lecture so that you can cover the topics parallelly. I will be taking up the lectures very quickly, or let's say in analysis way, so that you do not waste a lot of your time in watching the lectures. My lectures will be focused on discussing the results rather than deriving it. So I will always discuss the results, that okay, how we can look at the things from many point of views. And all the graph information which I'm giving has been asked to me in many interviews. So by combining all that information, I am actually taking this lecture. Okay. So now let's move to rational functions. So rational function is y equals to, so in numerator you also have polynomial and in denominator you also has polynomial. Both polynomials are of order 1. So you can see an example. So in numerator you have polynomial which is x, and in denominator you have polynomial which is x plus 1. And both these polynomials have order 1. Order 1 means x power 1. So when you have this kind of case, then your graph is hyperbola. So always remember, the graph for rational functions is always hyperbola. And how do you plot this graph? You can plot this graph by making asymptotes. What are asymptotes? So there are two asymptotes. One is vertical asymptote and other is horizontal asymptote. So how do we find the vertical asymptote? So vertical asymptote is defined as the point. So listen very carefully. It is a point where, so it's a point where y becomes infinity. It is a point where y becomes infinity. So let's see where your function is becoming infinity. So if your function is x by x plus 1, and if you put x equals to minus 1, your graph will become infinity. So at x equals to minus 1, your graph is becoming as, your y is becoming as infinity. So your x equals to minus 1 is your vertical asymptote. Now let's see what is horizontal asymptote. Horizontal asymptote is a value of y when x is infinity. So if you put x infinity, what will be the value of y? So let's see, this is your equation. Now what I can do is I can bring this x in the numerator. So if I bring this in numerator, you can see 1 by x divided by x will be 1 and 1 divided by x. So if you put x infinity, this term will become 0 and you will be remaining with value 1. So if you put x equals to infinity, your y value will be 1. So what is your horizontal asymptote? Your horizontal asymptote is y equals to 1. And what is your vertical asymptote? That is x equals to minus 1. Once you know this information, then you can easily make a graph. How? So let's draw your vertical asymptote. So your vertical asymptote is x equals to minus 1. So this is known as x equals to minus 1. So you can see x is equals to minus 1. So we made a line, vertical line at x equals to minus 1. And let's make a horizontal asymptote, which is y equals to 1. So we made a line at y equals to 1. So once you know these two lines, all you need to do is make one graph on these sides of lines and other graph on other side of the lines. So you can clearly see one graph is on this side of the intersection of the lines. So this is the intersection of lines. So one graph is on this side of intersection and other graph is on this side of intersection. So just make the two lines like this and you have got your hyperbolic graph. So one hyperbola is on this side and one hyperbola is on this side. So this is how you plot a rational functions. So whenever a rational function is given to you, find horizontal asymptote and vertical asymptote. Once you know vertical and horizontal asymptote, what you can do is plot them and then make hyperbola on one side of intersection and one hyperbola on other side of intersection. You will get your graph. Okay, so this is all about rational functions. I will be continuing next from here in the next lecture. Okay, so see you in lecture number 2. Read the notes. You can even solve the quizzes after this lecture. Okay, see you all. Bye bye.